Okay, this video I'm going to be covering questions 11 through 13 on the midterm review. So let's go ahead and get started with question 11. So the task for 11, which system of equations has the same solution as the system below? So here's the original system, negative 4x plus 9y equals negative 25, 6x plus 8y equals 30. Now, there's two things that we're looking for here, okay? One is that they must be multiplied. Actually, I'm going to put this in text. Believe it or not, I can actually type fairly fast. They must be multiplied by the same number and, all capital there, signs stay the same. Okay, so in order for this to work, we've got to multiply both equations by the same number. So when I look at number one, it's pretty clear that this top equation is being multiplied by 10. Okay, so and then when I look closely, it looks like the bottom equation is being multiplied by 10. So let's see what happens if I distribute 10 to every term in that first equation. So 4 times, or 10 times negative 4 is negative 40. But this is positive 40x. So right there, everything else looks okay. 90y and negative 250. But this first term right here messes it up. So even though I multiplied both of them by 10, because if I follow that through in the second equation, it's all good. 60, 80, and although that is a incorrect sign in between them as well. So this does not work because even though I was using 10, it didn't keep the signs the same, okay? There's no negative in between the 6x and the 8y. For this one, number 2, I'm going to multiply this by 5 to get the negative 20x and the 45y and the negative 125. So that carried through nicely. But if I were to multiply this by 5, I'm going to get some different numbers. Actually, it looks like to get the second equation for this one and multiplied by 8, which is a different number. So remember, they must be multiplied by the same number. This one does not work either. So now let's go to number 3. Number 3 should be pretty clear. They kept everything the same in the first one, right? Signs are all the same. Everything's good. So essentially the second one should be the same, but it's not. They multiplied through by 4 to get all of these. Now, the signs all stayed the same. This would have worked if the top equation was multiplied through by 4 also, but since it wasn't, number 3 doesn't work. So of course they save it for the last one to be the one that actually works. How do I get negative 12x? If I'm looking at the first equation up here, let me get rid of all that stuff. It looks like whenever I see a 4 and a 12, I'm thinking, okay, there must have been multiplying by 3. So times each of these by 3, distribute 3. Negative 12x, yep. 27y, yep. Negative 75. Okay, so did I do the same thing for the second one? I hope so. 3 times 6x, 18x. 3 times 8y, 24y. 3 times 30, 90. Yes, it is. So this one works. Good. All right, let's move on to number 12. Gary is solving a quadratic equation. Don't worry about that word quadratic if you have not heard it yet, although I've mentioned it before. It's irrelevant here. It's an equation. That's all you need to worry about. What kind of equation? What kind of function is it? not for you to be concerned with yet. His first step is shown below. So he goes from this original problem down to this. Which two properties did Gary use to get to step one? Well, I can see one property for sure. He did this, which to me says distributive property. So let me see. Do I see distributive property? It looks like I see distributive property here of multiplication over addition. Although we see subtraction there. Remember, subtraction can be adding a negative. So number 4. So I'm looking through here. Basically, it could only be choice 1 or 3. Okay. I'm looking to see, oh, it looks like these two terms got switched. Now, they are subtraction. But remember what I just said. If I'm going to switch some terms around, I can do that if it's adding. So if I turn them into adding a negative, I can switch them around and then turn them back into subtraction, and it's okay. I know you might be saying, wait a second, that's not okay, it's subtraction. It is because they're both, because I turned it into adding a negative and then switched them. It does work. So commutative property of equality, actually not sure if I like that, but commutative property and distributive property are the two, and it is choice 1. Okay, we have one more problem to solve. That's 13. Perform the indicated operations and write the expression as a polynomial in standard form. Okay, now, standard form is going to be the key. So here's what you're going to do. You're distributing the 2 first, and then you're also going to distribute the negative x. I'm going to do that all in one step. So 2 times x squared, 2x squared. No problem there. 2 times 7/8 is, 7/8 x is going to give me, it actually ends up being 14/8, which would simplify to 14/8 divided by 2 be 7/4 x minus 10. Then I have negative 3. Yes, that subtraction sign is going to carry like a negative. Times 3x is negative 3x squared. And then a negative times a negative is a positive 1/4 x. Okay, now I need to combine like terms. By the way, the first part of this is in standard form. Variables with exponents come first, variables without come next, and then terms with no variables go last. So the 2x squared and the negative 3x squared combine to give me negative 1x squared, or just negative x squared. Then my 7/4 x and 1/4 x combined to give me 8/4 x. 8/4 is 2x. And then there's nothing for the 10 to combine with, so minus 10, and I am done. So that's it. In order to understand this, you got to be listening. So hopefully that all made sense. If you got any questions about this, make sure you ask it in class.